Hello, my name is Kevin Hind, and this is a presentation on price elasticity of demand. Well, we've already learnt that the basic law of demand says that as the price of a good falls, more of it will be bought, and vice versa. So if the price of a good rises, less of it will be bought. And you can see this on the diagram in front of you. Price on the vertical axis, quantity demanded on the horizontal axis. And at a price of P, OP, the quantity OQ is demanded. As price falls to P1, then the quantity demanded increases to Q1. However, we're not just interested in movements up and down the curve for their own sake. We're interested also in the responsiveness of demand to changes in price. So for any given price change, there may be different responses in the quantity demanded. Here we have a diagram which shows a price, let's say, of £6. When the price is £6, 5 units are demanded. When the price is £4, then 6 units of this particular commodity are demanded. And you can get a feel for the revenue here, because the price is £6 and the quantity demanded is 5, then £30 in total is the revenue, 6 times 5. However, if the price is £4 and 6 are demanded, then the total revenue, price times quantity, is £24. Now, the issue of revenue will become more apparent in a moment, but for the minute I just wanted to say a little bit about the different slopes of the demand curve that we can see, and therefore the responsiveness of quantity demanded to changes in given prices. Again, let's go back to our example. When you see the price of 6 and the quantity demanded is 5, and when we have the steep slope demand curve, we call that inelastic demand, which we'll say a bit about in a moment. But when the price falls to 4, with a steeply sloped demand curve, the quantity increases to 6. However, when the price falls from 6 to 4, when we have a more shallow sloped demand curve, an elastic demand curve, the quantity demanded actually rises from 5 to 9. So what we can say is that when we've got a shallow slope demand curve, the proportionate change in the quantity demanded is much greater than the proportionate change in price. And let's just have a look at what that means. If price falls from 6 to 4, that's a 33.33% fall in price, but the quantity demanded, we've got an elastic demand curve, is an increase in quantity demanded from 5 to 9, which is an 80% increase in quantity demanded. So the price has fallen by 33.33%, but the quantity demanded is increased by 80%. Therefore, demand is relatively responsive to this proportionate change in price, certainly more responsive than the in terms of proportionate change in quantity demanded to the proportionate change in price. However, if the price falls from 6 to 4 and we've got an inelastic demand, the quantity demanded increased from 5 to 6. Therefore, the price fall was 33.33%, but the quantity increase is only a 20% increase. That's proportionately less. 20% is obviously less than 33.33%. So for any given price change, there may be these different responses in the quantity demanded, and that has important implications for revenue. And that's what we have here in this particular graph. You can see we've got an elastic demand curve, D1, and at a price of 6 and a quantity of 5, the revenue is £30. £6 times 5 units is £30. And as the price falls to £4, then the quantity demanded is 10. That means that the total revenue is £4 times 10 units that are demanded. That's £40. So in this particular instance, as the price falls, the total revenue goes up from £30 to £40. However, if the price goes up, if we went from £4 to £6, then the total revenue would fall. We'd move from the revenue associated with the £4 price, which is £40, to, when we put our price up to £6, to a total revenue of £30, so we'd lose £10 in revenue. So clearly you want to know something about your product, your elasticity, if you were going to thinking about putting your price up and you had elastic demand curve. Interestingly, the relationship between price and total revenue is different in respect of inelastic demand. If you put your prices down, you go from £6 to £4, then your total revenue actually falls, because as you can see from the graph on the inelastic demand curve D2, as price falls from £6 to £4, the total revenue changes from £30, £6 times 5 units demanded, to £4 times 6 units demanded, £24. So total revenue falls from £30 to £24. However, if you put the price up, then what happens is that the total revenue increases. So if you're at £4 selling demanding 6 units, then 6 units are demanded, then £24 is your revenue, and your revenue increases if you put up prices up to £6 to £30. So with inelastic demand, a firm that has a product which has inelastic demand can put up their prices and their total revenue will increase. If they put their prices down, then total revenue will fall. One other elastic demand curve that we ought to note is what's called the unit elastic demand curve. This is drawn as a rectangular hyperbola, and it shows constant revenue over the range of quantity demanded and price. So in this example in front of you, the price is £10 and the quantity demanded is 2, so that is in effect £20 of revenue. At a price of £5 we sell, so the quantity demanded is 4, so there is £20 in revenue. It doesn't matter which way you go up. If you go prices fall from 10 to 5, or prices go up from 5 to 10, the revenue is constant. A much better way of understanding elasticity is the elasticity coefficient, and we measure that in terms of the percentage change in the quantity demanded as a response to the percentage change in the price, or indeed, as you can see, the percentage change where the triangle is meant to be percentage change in quantity demanded Q over the percentage change in product price, where again the triangle represents change in. And we can express that in slightly more mathematical notation as the change in Q divided by Q, and all of that is divided by the change in P over the change in over the original price P. So that's the price elasticity demand formula: change in Q over Q divided by the change in P over P. And those of you with a knowledge of calculus will see that for very small changes we could change the small triangle to a dQ over Q divided by dP over P. But we can rearrange this formula, and that's what we're about to do in the next slide. And here all we've done is, because we've got the fraction, the change in Q over Q divided by change in P over P is really just a fraction, we've inverted the denominator, that's the change in P over P, and multiplied it. So now we've got the change in Q over Q times P over delta P. So the P over Q then is multiplied by the change in Q over the change in P. Change in and delta are the same terms here. So we're measuring what's called a point elasticity. And at the moment that probably makes little or no sense to you, but I hope in the corresponding in the next few screens it will become much clearer. What does the coefficient mean? Because we're going to get a number when we do the calculations, and so we need to understand what that number means. Well, the price elasticity of demand, as we've said, is the percentage change in the quantity demanded over the percentage change in the product price, and it's usually a negative number because it's reflecting the law of demand. As the price increases, the quantity decreases, and as the price decreases, the quantity increases. It would be a negative number, but we tend to ignore the negative sign and just concentrate on the order of magnitude. So we get a number, and if the price elasticity of demand number that we get is greater than 1, then we say that demand is price elastic. That is, that the percentage change in the quantity demanded is greater than the percentage change in price. So if we get, let's just use an example, if we get an increase in price of 1%, then, and the quantity proportionate change in the quantity demanded actually falls by, let's say, 2%, then we've got a number which is negative 2. The numerator, the percentage change in the quantity demanded, is negative 2 because the denominator, the percentage change in price, has gone up by 1%. So that indicates that we've got an elastic demand. The quantity demand is more than responsive to the percentage change in price. If the price elasticity of demand number is less than 1, then we say that demand is price inelastic. So the percentage change in the quantity demanded is less than the percentage change in price. And again, if we use an example, if we get an elasticity equal to minus 0.5, that's saying that if the percentage change in the price was an increase, let's say, of 1%, then the percentage change in the quantity demanded would be a decrease of 0.5%, or 0.5%. So that would give us our elasticity value of equal to negative 0.5, and we'd say that the demand is price inelastic. It's less than 1, that value of magnitude of 1 that we talked about. And if the price elasticity of demand is equal to 1, then we say demand is unit elastic. That is, that the percentage change in the quantity demanded is equal to the percentage change in price. So a 1% increase in price would lead to a 1% fall in the quantity demanded. And so intuitively what we're saying is that a 1% increase or decrease in price will have what sort of percent? Some X% change in the quantity demanded. Okay, but now we're going to put that into practice. So we've got a situation here. The price of a newspaper rose from £1 to £1.10, and its daily sales fell from 10 million to 9.8 million, because we'd expect that to happen, a fall in the quantity demanded from a rise in price. Then, but what would be the price elasticity of demand, and would the editor of the newspaper be happy and consider that situation if the daily sales fell to 8 million, not to 9.8 million? Well, in scenario 1, where the price rises from £1 to £1.10 and sales fall from 10 million to 9.8 million, then the percentage changing price is 10%, because the price has gone up by from £1 to £1.10, and the daily sales, which we can interpret as quantity demanded, have fallen from 10 million to 9.8 million. That's a 2% fall in quantity demanded. So here we can say that obviously the proportionate change in the quantity demanded is less than the proportionate change in price. We've got inelastic demand. The elasticity number we get is negative 0.2, and we can see that total revenue from this particular price rise is actually increased, because we've got the proportionate change in quantity is not enough to offset the proportionate change in price. So total revenue initially was 10 million when the price of the paper was £1. We sold 10 million. The quantity demanded was 10 million. Now the price has gone up from £1.10. We're now selling, quantity demanded is 9.8 million. So £1.10 times 9.8 million is 10.78 million. So yes, the editor of the newspaper would be happy with an increase in revenues, even though they've lost some readers. In scenario 2, the editor of the newspaper wouldn't be so happy, because obviously what's happened is we've got a larger than proportionate increase, or decrease I should say, in the quantity demanded. The sales have fallen by 2 million, and that's a 20% fall in sales. So this time the percentage change in the quantity is minus 20%, from 10 million to 8 million. Percentage change in price is still the same. It's a positive 10%, £1 to £1.10. So we got an elasticity value of minus 2, and that means that the total revenue falls because of this large change, or large proportionate change in the quantity demanded. Total revenue falls from 10 million to 8.8 million. We were selling 10 million papers at £1 each, and now we're selling 8 million papers at £1.10 each. So the quantity demanded has fallen, and that's indicative of what we've been saying, that when we've got inelastic demand, you can put your prices up because your total revenue will actually increase. And one of the reasons for that is that there might be seen to be few substitutes for your paper, or you've got a good brand. And when you've got an elastic demand, you don't want to be putting your prices up because your revenues will fall. It's also important to say something about the slope of the demand graph, because the slope of the demand graph and the elasticity number that we generate are not exactly the same thing, and we'll see why in a moment. Here we have a demand graph. We've got 7 points on it: A, B, C, D, E, F and G, indicative of various price and quantity combinations. So when the price is 6, quantity demanded is 0, we're at point A, and when the price is 0, the quantity demanded is 6, we're at point G. Then we've got points B, C, D, E and F. And this is a straight line graph, so its slope is constant. And if we were to show a movement from A to G, we know that if we took a measure from A to B and looked at the slope there, it would be the same. But we just take a movement from A to G, then the slope, which is the change in P over the change in Q, because what we have is the vertical axis here, it's the change in P, and the horizontal axis is the change in Q. So if we move from A to G, we get a change in price of minus 6, we go from 6 to 0, and the change in quantity is plus 6, we go from 0 to 6. So the slope is equal to negative 1. It's obviously a negative number, because as price falls, goes in one direction, the quantity demanded goes in the opposite direction, so it's negative. But that's not the same as the elasticity, because if we look at just a movement from B to C, right, so that the price was £5, and we're going to put the price down to £4, we're going to go from B to C. Well, in that particular instance, the elasticity, which is the percentage change in the quantity demanded over the percentage change in price, the percentage change in quantity demanded is when we move from B to C, is from 1 to 2, so we get a 100% increase in our quantity demanded. The price has gone from 5 to 4, so that's a 20% fall in the price. So our elasticity coefficient, elasticity number, is negative 5. But that's very elastic, so that's an interesting point, because what we find is that in the top portion of the demand graph, we get elastic values for demand. The proportionate change in the quantity demanded is actually considerably larger than the proportionate change in price, and you'd expect that actually at those low quantity levels and the high prices. If you look at E to F, which is another interesting point, shows you a different value of elasticity, because here we're moving from a price of 2 to a price of 1, and the quantity changing from 4 to 5. So here the percentage change in the quantity from 4 to 5 is a 25% increase in quantity, and the price has fallen by 50% from 2 to 1. So here we get a negative 0.5. So what we have here is an inelastic value for the elasticity coefficient, the elasticity number. And so what we find is there is a real difference between the slope of the demand graph and the coefficient, the elasticity coefficient, because it depends on where you start from on the demand curve. At the upper end of the demand curve, in fact from points just above D to A, we've got elastic demand, and from points just below D to G, we've got inelastic demand, and at point D, we've actually got elasticity equal to 1. And that point is represented here. We're saying that the price elasticity varies along the length of a straight line demand curve, and you can see the elastic proportion at the top part of the demand curve and the inelastic measures of elasticity in the bottom part of the demand curve. And we've got points like when quantity is equal to 0 and the price is its highest on the demand curve, elasticity equal to minus infinity. It's very, very elastic, perfectly elastic. And when price is 0 and the quantity demanded its highest amount, then elasticity is 0. And what we're saying there, it's very inelastic there. Quantity demand is very inelastic in respect to price changes. And it'd be quite nice for firms if they know where they're operating along the demand curve. If you're operating along the inelastic portion of the demand curve, then really you should be thinking about increasing your price. And indeed, if you think about it, it's quite natural. If you increase your prices, you're going to increase your revenues. Obviously, you're going to sell less, but that means probably your costs might be falling as well. And indeed, we find that firms, if they're going to maximise their profits, actually must actually price in the certainly if they're monopolists or got market power, must price in the elastic range, because that's where they get their maximum profit. Okay, let's go back to our demand curves. What we're saying in effect is that when we draw an inelastic demand curve, we're suggesting that we're analysing the inelastic portion of the demand curve. And when we look at an elastic demand curve, we're looking at the elastic portion on the demand curve. And I think that's fairly self-apparent from the diagrams. But clearly, what we're suggesting on the inelastic demand curve, we could extend our demand curve right up to the price axis. We could say that we were considering the inelastic portion of the demand curve, and with the elastic demand curve, we're clearly considering the top part of the demand curve, and the dotted line extending down to the quantity axis much further along than we can actually see on this screen. Here are just a few other demand curves, just to make our point. We've already mentioned when elasticity is equal to minus 1. I've used the Greek symbol eta here, n, looks like an n, but it's eta for elasticity, which you might see in some textbooks. And so demand curve 3 is a unity elastic demand curve, where elasticity is equal to minus 1. When in curve D1 is when we get perfectly inelastic demand, inelastic demand, elasticity demand is equal to 0, and that's a vertical straight line, very, very steep indeed. And when price is perfectly elastic, demand is perfectly elastic, we get price elasticity demand equal to minus infinity, and that's a horizontal line. It's suggesting at a given price any amount will be demanded. Okay, so we need to look at the factors that influence price elasticity of demand, and I've put down a number here which I think are relevant, and indeed there are a multitude of influences on the price elasticity of demand. A key aspect is the availability of substitutes. If there are many substitutes, then demand is clearly going to be price elastic. It's very basic economics. If somebody puts up their price of their good, then people will switch to another good, and you will lose out if you're a firm engaged in raising your prices. And clearly, as we've seen already, if you've got price elastic demand, you raise your prices, you're going to suffer losses of revenue. However, if there are few substitutes for your product, or few substitutes for a particular product, then price is inelastic. It also matters in terms of the product category. This might sound a strange thing to say, but we normally find that when the broader the category of product that we're looking at, then you find that that you've got more inelasticity. So if you take a product like clothing, there are few substitutes for that broad category known as clothing, so you'd see that demand would be price inelastic for that. But if you come within the category of clothing to something like jeans, you would see lots of substitutes for jeans, obviously not just in terms of jeans, but casual trousers generally. And even if you were in the jeans market, you would see that there was a lot of competition, and so then you'd see that that jeans would be more elastic, have more elastic price elastic demand than the category like clothing. Advertising obviously makes demand more inelastic, and that's an important feature, because what you're doing is trying to create a brand attachment to a product, so that when prices increase, you don't tend to get the proportionate change in quantity that you might expect if your good was elastic. Also, the type of products matter. If you look at if you're buying goods which you consider to be a necessity, then price changes actually won't have much an impact on your demand. That's the same for addictive or habit-forming goods. So if you're addicted to products, then price changes mean that, or don't have a proportionately large change in the quantity demanded. Luxury goods are also interesting, because the thing about with luxury goods is that if you put their price up, then you tend to postpone them. So you find, certainly in the short run, that luxury goods are things that can be postponed, so they become quite elastic, price elastic. If you put the price up of a luxury good, people will postpone their purchases. A number of other factors also influence price elasticity of demand, and the first one we've suggested is related to the issue of luxury products we just mentioned, the price of a product relative to income. So you find that the greater the percentage of income that's spent on goods such as cars, then the more elastic that the good is. So the more important that is in your total income, the more elastic that particular product is, more price elastic it is. So if you put the price up of a good, and you've got a high proportion of your income is spent on that good, you tend to be much more price elastic. Very importantly, I think, just to finish on these factors influencing price elasticity demand, is the role of time. And we can think about the difference between short and long run elasticities. First of all, let's look at durability of a particular product. You find that when you have durable goods such as televisions and cars and white goods, then in the short run, when price increases, that leads to individuals postponing their purchases, so demand is elastic. But in the long run, individuals actually have to replace cars, TVs and white goods such as fridges and so on, and therefore demand tends to be a bit more inelastic. So that's a slight change in what you might think. But also tastes and preferences can change over the long run, and so ultimately your elasticity can change one way or another. Goods that were once not very price sensitive now become very price sensitive, and again you might link that to the product life cycle. When you have new products, they can be very price inelastic in demand, particularly as you get through a stage of growing sales. People get an attachment to them, they're trying them out and they seem to want them. Another factor which affects the long run elasticity is things like price volatility. And if you've got very volatile prices, and I'm thinking here really about oil prices, although they're not volatile in one sense, but they certainly have had some peaks and troughs, and indeed seem to be on an upward movement at the moment. But what you find is in the short run, people require things like oil for energy needs, their everyday energy needs, and therefore it's very price inelastic in the short run. But over the long run, people will actually change their consumption habits. They will look to more energy efficient ways of using or consuming goods and services. So they'll be looking at, for example, battery powered cars, or using gas in their cars as opposed to petrol, or they'll be looking to use different sorts of energy instead of oil to heat their houses, and so on. And companies will be doing the same with certain products that are maybe oil based. So in the long run, you find that oil is price elastic because of this problem with price volatility. Finally, I thought we ought to end just on some examples of own price elasticities in the UK. The term own price is one that's often used. It's indicating the price of the particular good. And here we've got some elasticities for the UK. They're all negative numbers, obviously. As the price goes up, the quantity goes down. But bread and fuel and light and even alcohol are what we call price inelastic in demand. Services and entertainment are price elastic. They've got values greater than 1. So just to make the point that I made earlier, if you look at bread, a 1% rise in bread, or if you like a 10% rise in bread prices, only leads to a 2.2% fall in the quantity demanded of bread. If you look at entertainment though, a 10% rise in entertainment prices would lead to a 14% fall in the quantity demanded of entertainment services. Now these are quite broad categories, and one can actually get within categories, and there's nothing to stop businesses or any organisation actually examining price elasticities within narrower categories of the particular good. Certainly firms can calculate the price elasticity demand for their products, and they in doing so they'll get an understanding of the impact on revenue and on the nature of the product that they have. The measures that we've used have shown some of the principles of how to calculate elasticity. In practice, we use much more sophisticated techniques. I've already alluded to the use of calculus, but actually statistical techniques are used, and those help to get some understanding of what price elasticity is all about. Thanks very much for listening.